Okay, we're back. And then Peter, I'll start you off with your 30, and then we'll just interrupt with questions. I presume you have a little bit that you want to get through, and then we'll.
Yeah,
Okay.
let's do it that way. I got my screen up. So yeah, the big model that Saar's presented is this exponential thing where it grows faster within the market than outside the market, and that's kind of how he salvages the lab leak theory because it's this really great spreading location. So I've been trying to understand this model. First off, I want to point out that the age component of it, this is simply wrong. I didn't realize this in the first debate. I hadn't looked this up, but the cases at the market are younger. So, but I'm going to ignore that for now and just try to use the numbers that he did. We actually have data, so I want to see how this compares to the data. And the interesting thing here is that the market and the outside grow at about the same rate. It's actually slower within the market than outside the market if you graph the cumulative. And Rootclaim has to be aware of this because actually this was their first week slide where they point out that these grow at the same rate. And at the time that was their argument against the market, and now it's that the growth rate is higher in the market, and that's their argument. So that's changed. The other thing we can do is we can just calculate the growth rate in the market from these case rate maps. We don't need to speculate about it. So, the first week it's 3, then it's 8, then it's 27. So it about triples in cases each week. And we know from all these other studies that the rest of Wuhan, it quadruples every week. So the growth in the market is actually less than outside. So that just demolishes this perfect super spreading location theory. Doesn't fit the data. The other thing to wonder is why is the west side this perfect super spreading location, but not the east side? In the market theory, this is easy because the animals were over on the west side and the early cases are there. But if we're saying it's because of ventilation, temperature, all these mysterious factors, organic material, whatever SARs think is important, the east side should have those factors too. The west side, those should be shared. And so the only thing I can think that would maybe salvage this is the mahjong room is on the west side, and he thinks that it's the perfect combination of only market conditions plus a mahjong room is the only thing that can be a super spreader location of all the 10,000 places in Wuhan. And even then, the cases that are closest to the mahjong room aren't positive until the third week. I'd say this is a gain of function theory. Basically, it's only the combination of those two. I'd talk about the history of this theory again. Why this exists in the first place is because Warabi made this map, and they're saying with these samples, hey, look, the samples are around the wildlife. So the lab leak needed some excuse for why it still holds. And they said, hey, we can, Texas sharpshooter the bathrooms right in there. And then that salvages the lab leak theory. And then that morphed into the mahjong theory over time. This map's a little bit out of date with the latest data. This is probably a slightly better one. You got some kind of cluster there. But the thing is, both of these are over smoothed heat maps. There are actually no positive samples in the mahjong room. You can only if you smooth all these other market samples, you can make it sort of point towards that corner. And this is also funny. I talked about this in the first debate that outside the market, they say that because the cases are centered on the market, that's meaningless. But inside the market, that's proof of the mahjong room. The other problem with Rootclaim's new theory is they don't have this explanation. They're saying that there's lots of cases outside the market before the spreading event at the market. But then if those outside cases, those 128 kept growing, they shouldn't be clustered on the market, centered on the market. So there's no explanation for that. They also have no explanation for why the cases outside the market spread away from the market over time. We know how that happened week by week. They start right at the market. They grow further and further away by week. So none of this fits the data at all, but I really just wanted to understand whether this can work at all for fitting the data. So I read all the details he used here, and I tried to reconstruct this in Excel. So this is the graph he put in. This is my graph. I think these are identical. I think the X scale is slightly different here, but it's his model. And I tried to compare these to the data. So these are inside the market. Kind of works. I think his curve's a little maybe too steep, but whatever. Outside the market, blue is the recorded actual non-market link cases. Orange is what he simulated. So you've got, at the time Wei Guizhang gets sick, you should have 20 hospitalizations outside the market and 1 for the market. And by the time Chen gets sick, you should have 30. And And that's not what they're finding in hospitals. What they're finding in hospitals is 1-in-1 roughly, or even more than 1-in-1 for market versus. So you need to explain this 20 to 30x bias on the hospital searches, which, it's theoretically possible, but it's a very strong claim you're making with no proof. The other problem is if you extend this model out past December and you take the slow growth rate he's assuming outside the market, that's the orange, and you compare it to the actual case data outside the market, it just loses the connection at all because the outside the market grows, at the normal rate, the quadrupling every week, whereas his model is slower than that. So I think the only way you can maybe salvage this is if like lineage A, lineage B are dramatically different, like the doubling rate of one of those is double the other. But I think that I don't know if they've even thought of this problem, but maybe that's why they keep talking about lineage A, lineage B to salvage that. And we know that this just isn't true. They're very similar, those two strains. They're always like B is 2/3 and A is 1/3, like everywhere in the world for the first few months. And that's even true like in Jesse Bloom's data. That's true in Zhongnan Hospital right next to the Wuhan lab. This math is also kind of wrong. Like it's 128 cumulative days. Like the odds they'll get to the market in the first place are wrong, I think. But I'll yield for now. I just want Saar to explain how does that work in your model?
Okay, so west side. I don't know what's special with the west side. Could be ventilation, could be temperature, could be coincidence. The point I will be returning all the time here is that you can't claim a very high base factor when there's a lot of complexity. If we work for 1 year and manage to get all the data and exclude any possible confounder, then maybe one of us can claim something strong about this. But these are people, these are cases that are unreliable, there are manipulations, there are politics. You don't know what's wrong with the data, right? I don't know. So I worked for a long time on the first claims. I found a few directions that show why HSM could be a likely early cluster. As I said, it's not a perfect model because I don't have all the data. I just showed, just to understand the importance of exponentials, to show that how that could work. If we work for a very long period of time, maybe we'll have a perfect model, or maybe we will be able to exclude a perfect model. Okay, that will take time. But the main issue I'm returning to is about the meta inference. When one side only has claims that are based on very complex models that need a lot of things to be correct. So this case data needs to be correct, and the models need to be correct, and everything needs to be correct. So when that's the only thing you have, you likely don't have the right hypothesis. So we can go into this. We can do another session, and at some point we'll be discussing whether the swab used for A20 is one that has a 0.5 or 4% error rate or something. We will be discussing details. It doesn't matter. At the end of the day, you need to look at what kind of evidence each side has. One side has evidence with robust, well-established base factor, high base factors that the other side cannot explain. And the other has all kinds of very complex models which claim very high base factor, but once you pull one of the legs, it all collapses. So we can go for another session, and I will go deeper, and maybe my model will be better, or maybe a little bit worse. I know. But given if we try to extend what's going to happen, maybe I will share. Can I share, please?
Oh yeah.
So if we try to simulate what will happen if we do this thing to infinity, right? So this is what we say. We're getting into very minute detail. Our main insight is you don't need to do that. You don't need to explain everything. You just need to show that the pattern of your evidence fits better one side. So let's imagine what will happen if we continue like 10 more sessions or 50 more sessions of this. So what will happen? We'll find more evidence. Peter, I think everyone can agree, has much more knowledge on origins than we do. He's invested much more time. He's maybe a much more talented researcher. He's much more into the details. He probably knows the best in the world on origins at this point. So what will happen is we will have time to look into more evidence, something we hardly did because we were mostly looking into quantifying the existing claims and less about finding new ones. But the little time we did invest, we found an interesting thing, like the study showing that 4 of 6 positive civets in a random market were all SARS positive. This is completely different than what we have in SARS-2. The corner read case, which is very strong that itself just shows you that the whole market claims are wrong. It's just impossible that this holds. Chen alone also is very weird for the market. We will find more factors making HSM a likely early cluster, and maybe we will be able to match Peter's objections better, and the model will be better. The opposition has already invested enormous resources. Probably won't be finding new evidence. We'll continue to find more mistakes in the complex modeling studies that are the only thing that supports zoonosis. Remember that was a lot of work to find the bug in Picard, and it was a lot of work for us to find how irrelevant is the WRB data from the check-ins. It's a lot of work, and we will do the work, and eventually all the studies will probably be obliterated, and maybe 1 or 2 will survive. But who's to say that the one that survived is the zoonosis study? It could be the Lably study. It could be the one where they show that restriction sites are arranged in a way that matches engineering. I mean, it's just we don't know what will happen. So we'll find more cases like what happened with Picard, where a base factor that starts with 200x turns out to be 4x and practically 0 and 1. It won't happen to our side because we already account for all these possible mistakes, and we don't use such shaky data in our analysis. We may find more biases explaining why the data that everyone based our research on is invalid. We find more reasons why the models are irrelevant. I showed in this session a few cases where the opposition has provided evidence in a way that is not accurate. We'll find probably more of those. Peter will find more Rootclaim mistakes, which he did find, but they won't change anything because we already built them into the model. We built the probability that mistakes will be found. So we found the mistake we said about early visitors, but it doesn't change anything because they're anyway not involved in wildlife. So that was the essence of the evidence. We claim to have several early clusters. I tend to agree that HSM is probably the only one, or maybe one of a few, but we already gave it the modest base factor because we didn't have high certainty on that. And then we also discovered why it's not relevant. I mean, why HSM is likely to be an early cluster. So on the other hand, we'll find underestimates. So every time one of our base factors will be knocked down, others will go up because we leave the room for that, right? So I said the FCS is a 50, but I forgot that even if the 2% that they find a good reason, that won't be 100% reason. To the reason why it's a 10% event. So that's actually 500. Following Eric's questions about Wuhan, we found out that the 1.5% was wrong because we didn't count for the fact that the wildlife is mostly a South China thing, right? So SARS happened in the city where there's the most wildlife trade. Wuhan is not like that, so we should have accounted that. So 1.5 is actually 0.5%. We didn't account for the fact that there are no spillovers, which is very weird given the studies we just found. We only account for no intermediate host found. Right? So there's a lot of stuff that will grow as we research more because we leave the room for that. We don't start with the most outrageous unlikely explanations and then cut them as they fall down. But what will happen is there will never be an explanation why the FCS looks that way. I mean, there likely won't be an explanation for that. There won't be an explanation why this whole thing started in the most likely city in the world for such a lab leak. It's the most likely because UNC wouldn't do it in Bristol too. Why it looks exactly like a diffuse product, and why there is no other spillovers anywhere in the world that come from wildlife. So that's what will happen if we do this for 20 more sessions. And the bottom line is that the evidence for zoonosis is surrounded by a lot of complexity and uncertainty. Further investigation may strengthen some, may weaken some, we don't know. The lab leak evidence is robust, it won't change much, it won't be much weaker, much stronger. We have a good sense of what it is. Now this is the key point here. So this is important. So, So if we try to think what will happen if we do this for a long time, it's unlikely that there's strong evidence for both sides. It's just by definition. The definition of strong evidence is something that has a low condition probability under a competing hypothesis. So by definition, you won't have strong evidence to competing hypothesis. So if we need to guess what will happen, since one side has robust evidence, the other has shaky, complex modeling evidence, we'll need to assume that what would happen is that the zoonosis evidence will go weaker and weaker, because that's the most likely, that's the more likely thing to happen. We therefore don't need to continue discussing the evidence. We just look at the pattern of the existing evidence and have a clear picture. I just want to say another thing. Yeah. No, that's enough. Okay, so I don't know the answers to Peter's questions. I can say that the data on which he's basing that the case growth is different than our model is unreliable data. You may look into it for a long time and find a problem, or maybe we'll find it's not a problem, then we'll need to adjust the model. Maybe we'll have a good model, maybe we won't have a model, but there's a lot of uncertainty there. He's asking about the centering. Again, it's bad data. It was fed to the WHO by China when they knew what this data is going to be used for. And it also could be a coincidence. So again, the coincidence is not that all the cases by chance center on the market. It's that within all the high density neighborhoods, it's a coincidence that the HSM neighborhood is the one where it grew faster, right? That will also explain why HSM is the first cluster, not some other weight market. So it's not some crazy p-value that it will center. It just can be some other reason other than HSM. And then again, we need to remember that Chen and Connor, they basically obliterate the whole claim that early cases are reliable. They show that there are many cases outside HSM in early December. I mean, the fact that we have Connor, which is
should we talk about Connor maybe instead of just you repeating over and over? All you're just saying over and over is the data is shaky and you don't like complex models. And just because you don't understand the complex models doesn't mean they're wrong. Like you failed to make an exponential. You didn't even account for time in the first debate. And now in this debate, you've made an exponential that's wrong. And you've said that all the data is false if it doesn't agree with your narrative. And you're saying that it's obviously lab leak because there's a cleavage site and it's in Wuhan. That's your case.
No, that's not my case. My case is a bit more...
or in CGG, Yeah. But you refuse to interact with any of the data. You've declared that the fact it showed up at the market is base factor 1, that the case that the lineage A cases were close to the market is base factor 1, that the data within the market suggesting infected animals is base factor 1. That's just you ignoring the real data over and over and over. You didn't look at the growth rate within the market. You didn't look at the age within the market. And so we can continue this indefinitely, like you said. And it's basically like you're going to add epicycles to your theory to make it continue fitting. And that's why sometimes I'm presenting these at the debates, not before, because I'm just showing that you haven't even thought about these issues. If I tell you this stuff a week beforehand, maybe you can come up with an excuse why your theory still works. And now you've added, it's the wall of the market where the ventilation is worse. But that doesn't even fit because you're also saying the reads are too low in that area and the read count is higher in the other areas. So there's no consistency there. You can keep making excuses for 20 debates, but you still have no evidence. All the evidence points to the market.
Right. So say that it didn't interact with the data is obviously one. We showed how Warby is completely using false data.
What's false about it? Explain that.
Saying that the locations that they call markets are more likely than HSN to be an early cluster. These are supermarkets. These are department stores. These are.
Why can't it spread at a supermarket?
Because of all the reasons we showed, and because we don't see it in the data. We don't see supermarkets and the department stores being a major early clusters anywhere
But
else.
I showed studies from all over the world showing that they are. I showed studies all over the world showing dozens of different types of spraying locations.
You showed so first of all, specifically supermarkets and department stores are not common, and these are.
They were in Seattle and New York.
These are not early clusters. Early clusters require it to happen when there's very little infections. So
that's your theory that you've made with no proof.
I don't know what it's a model. Yeah, it's
and it's a bad model. I just showed you the growth doesn't fit your model, doesn't fit the data. You need this model to salvage the lab leak, but that doesn't make the model true. You want this to be true, otherwise your case falls apart.
So it doesn't fit the data, which is very unreliable and is and has very strong counter arguments.
And the data is unreliable when you don't like it, but like Connor Reed, you think is 100% reliable. Also, like China says they tested 80,000 animals and didn't test any positive, and you trust that with 100%, even though China probably wouldn't disclose at this point because they say it didn't start in China. But you say that the WHO data from China, so you're picking and choosing even when it's China as the source, which you believe based on which hypothesis you want.
There's a very good reason to test animals and report on that truthfully, because initially they did react to this like SARS-1. They did want to find the source. They did do the zoonosis research. It's only a later thing, mid-2020, where they started to blame other countries. So this is very different. And specifically for WHO, the data they gave them is very likely to be against a lab leak, but it's not that likely to be against zoonosis. And you also need to remember China is just one country. So we could have animals anywhere else in the world turn positive, right?
But other countries don't have sarbecoviruses, and they don't have raccoon dogs in markets. You're not going to get a spillover in America of a sarbecovirus in a raccoon dog.
No, you could just go to countries bordering China and find in nature whatever the integrated host is. But I want to say something
about... Like we found the bats that were 97% similar.
Yeah, sure, but that's not a progenitor, right?
But that's not important evidence.
Can I ask some questions here? I mean,
I'd actually like to present a few more, if that's okay. If Saar can yield the screen, and then we'll do judges' questions.
Okay.
Let's do more data and less arguing, maybe. So more about why the markets are the only spreading locations. I think you failed to understand aerosol transmission in a lot of these. You're trying to come up with excuses like they wipe down the surface in schools, and kids are not hygienic at all. But they you go to any preschool, they spread any diseases. Hospitals, there's tons of COVID outbreaks in hospitals. Buildings, disinfection. I mean, at the beginning of COVID, I washed my groceries because I thought fomites were an issue. I don't do that anymore. That's not an issue. It's they swabbed the subway in London, and they can even find they can find any environmental samples on the subway. It's aerosol transmission that matters. You've also failed to understand the importance of this list. You keep saying that these are markets, and like markets amplify community transmission, but actually the key part here for all of these is imported, not market. And these are the places where COVID comes in from outside of China. So this actually confirms why Huanan is important, because it brought the infected animals into Wuhan from other locations. So that's what's important there. You talked about the mahjong table. Do you know what street the mahjong room is on, Saar?
4?
It's on 5th Street. So street number 5 and vendor not applicable. So for every other sample in the market, they list the vendor number and the shop number. So how we know this is a mahjong room is because it's street 5 and it's a vendor not listed and it's a mahjong table. So that's far and away the most likely explanation. I didn't crop this out to try to deceive you. I cropped it out so you could actually read this on the screen. Okay, maybe there is another not-listed place on Street 5. You're talking about SARS. You're saying that like 8 out of 20, but that's a study on antibodies in traders. That's not, we don't have antibody data there. We can talk about Connor Reed if you want.
I would like to hear about Connor Reed.
Yeah, so I wasn't trying to deceive with him at all. So I figured out his address also. I did this sleuthing. I let me talk about my motivated reasoning because I have some myself. My motivation is to not lose $100,000. So I made this bet with Saar in February, and then we didn't actually sign it till like September, I think. So I spent the 6 months in between trying to figure out if there's any evidence at all that can break the market case. And I was going to just pull out at that point because I'm not like wedded to this. I'm not a zealot. I just think it's true. And I think, and every time I looked, the case actually fell apart and so supported zoonosis better. So this is what he said about where he shopped. He said, maybe I caught the coronavirus at the fish market. He didn't specifically say Huanan. He talked about news reports about the fish market. So presumably if it's news reports, they're talking about the same Huanan. He said the news reports talked about koalas. So I looked up, this is a menu of one of the shops. It's called Mahjong at Huanan. These are all the animals you can buy there. Nice, healthy dinner. One of these is koala, but it's actually a mistranslation. It might be bamboo rat or something like that. So, I mean, what are the odds that there are two seafood markets that both sell koalas? And I'm pretty sure he's talking about Huanan market. I mean, it could theoretically be another market, but Rootclaim didn't prove that. And, this guy, Gilles Demaneuf, probably said that, but Guy is really not a good source. I can get into that. We don't actually know if Connor got sick. He says that he got a positive test from the hospital, but he's not listed in any reports. He's not listed in any hospital records. He just says in an article the hospital contacted him. He's 25 years old. I mean, what are the odds a 25-year-old actually goes to the hospital for COVID? He says his cat died from COVID. Saar said something else. I mean, you can give me a link, but this is what I read in the article. That's extremely unlikely. I've never heard of that. I think he's really just making up a story to get it in the newspaper. We also can't ask him for details because he overdosed on drugs a year later. So he's dead now.
Peter,
I don't think
the quote you gave from Connor, can you tell me when that quote was?
We can look.
I just want to know because obviously if he's making things up, it's going to be influenced by
March 4th, 2020. So at that point, he's probably already heard about like cats getting COVID. He's definitely heard about Huanan. He's definitely heard about, he has all the details to put in his story. Just one suggestion, if we can include tabloid articles, when I was a kid, this is what they had in tabloids. This could possibly be patient zero.
The Guardian, you can look directly at the interviews.
Yeah, and I think maybe you should do Bayesian analysis on the inputs in your model. This would be one suggestion for how Rootclaim could get things wrong or get things more right. Like, let's say, okay, we're not sure if we trust it. What are the odds a 25-year-old needs hospital care for COVID? You put that in your model. You say, what are the odds his cat died? You say, you like these little 2x multipliers. Let's say drug addicts often lie, or his disease progression sounds fake. And also you have this model that at the time 150 people in Wuhan have COVID, maybe 1% speak English. So you could have one person that would be Connor, but it's pretty unlikely. And you should have 100 interviews with Chinese people that, sleuths would have found already. I think we basically need a root claim within a root claim. You can't just trust the evidence that you like and say that that's 100% correct and therefore it supports your model. You need to evaluate which sources are good. Because if you just say the WHO report is all wrong and Warby's a liar, but this Connor Reed guy, this proves the whole case. I don't think that's a great way to solve it.
Yeah, so I'm not saying Connor is 100%. I'm saying there are many ways where this can fall. So Connor Reed is one. Chen is one, the genetics is another. So there are a lot of things that the market model needs to hold in order to survive. All of these legs need to be correct, right? All the
Right.
coming
But
data.
if a single one of these was correct, it would have already been proven. That's kind of the thing. All you would need is one accurate case in the last 4 years. Like, I wouldn't believe the market origin if you had like an actual positive test before the market. I mean, that would disprove it. The fact that you have not found that patient in 4 years of searching, that alone is strong evidence that the market case is good.
Right, but because you're relying on a source that wants it to be.
The source what?
China wants the market to be.
No, they don't. They don't say it's the market. They say it came from outside China. They would fake it. If they want it to be true, they'd fake an animal. They could do that at any time and just say, "Hey, we found the animal." Why wouldn't they do that?
So that's not how fabrications work. But let's not go. I mean, this will be an endless discussion. I'll try to. So quickly, the things you showed there about Connor Reed in your mini probabilistic model, these are all confirmation bias. So there probably were multiple 25-year-olds that got sick. They just didn't go to the hospital and have.
But there's 150, so the odds that one speaks English is like 1.5. That's how many you have in your model. You already came up with numbers of how many people are sick. So we already know there's not going to be, 100 Connor Reeds. If your math wouldn't work.
Just need one to go to. It's not like he died. He just went to the hospital because he didn't feel well. He got.
Yeah, but how often does a 25-year-old go to the hospital for COVID? If you have one Connor Reed.
It was a few hours in the hospital, right? We're not talking about.
And how does the hospital know he had COVID then? Because this is November before they had COVID tests.
Yeah, because they retrospectively took checked his sample.
And so he went for 4 hours and they saved a sample and then it tested positive later. And then they didn't record this in any papers because China is lying.
I don't know if it's not recorded in any papers. I didn't.
It's not. Otherwise, he'd be in the government reports and he'd be patient zero. Okay,
yeah, but again, you've seen how many mistakes they have in the early cases, right? You've seen Chen, you've seen the familiar cluster. This is not reliable data. There are many errors there, and Connor is somewhere where you want an error to happen. So anyone can take him out if because it points to value. Maybe he has a friend who's family of someone that I don't. There's so many things that could happen. So what you brought there is. Stopped. Okay, never mind. Also, calling him a drug addict. He was a teacher. Yeah. So,
yeah, and he died of overdosing on drugs. I mean, it doesn't not mutually exclusive.
Yeah, we're not talking about a dysfunctional person. He's just a guy.
Yeah, but people do attention-seeking things. You have to compare the odds that it's attention-seeking behavior versus he actually is the secret patient zero that proves your case.
That's a fair comparison to do. We can do that, but.
So you were talking about Gilles Demaneuf, and this came up in the first debate. I didn't have time to debunk it. You said there's 90 early cases missing, and the data is biased. So this is another one that I found while I was trying to figure out, like, should I do this debate? Because if this is true, I'm going to drop out of the debate. And I debunked it, and it's wrong, and it's hilariously wrong. But he actually got into the Washington Post somehow. So he says. Well, so the first thing I've noticed, this is a common thing I've noticed with a lot of misinformation, is they frequently tell you what their sources are, but they don't actually link to them. They just say like, oh, here's, you could not ask for better data sources, but he doesn't link to them. I've noticed this a lot with the anti-vax people. It's very much like saying there's nothing up my sleeve. And then they like underline the wrong numbers from the paper. And so the purpose of his project is to say there's 80 unreported cases in December and there's 9 in November. And then I went to those two papers and I actually read them. And the first paper said the first case is in December 8th. And the second paper says the first case is December 8th. So neither of the papers actually supports what he said. He's just saying something else. And the second thing, his goal is to prove that there's like 200 plus cases, 260 cases overall. So you can look at the first paper. He's trying to say 260. The paper actually says there's 146 cases up to 29th of December. And the WHO report says 174 cases up to December 31st. So that matches. You can, the paper actually gives this map, which shows that like Huanan is the epicenter, just like every other data source. And so I went and talked to him on Twitter and said, these two papers say it starts in December 8th. How does that prove there's cases in November? And he says that the text says one thing, but the figures are trying to hide the key data. And so what he's actually done is that there's a bunch of papers that they divide up the cases into lab confirmed plus clinically diagnosed. So it'd be like, 100 lab confirmed plus 70 clinically diagnosed. I might have those backwards, and that's 170. But then another paper just says 170 confirmed cases to use the total. So he noticed that if you misread one paper and read the word confirmed to mean lab confirmed, and then add the numbers from the other paper, you get a bigger number. So that's why the 90 come from. He just double counted 90 cases across the two papers. It's this clever sleight of hand. It took me a couple hours to figure this out. And you can tell, if you map the numbers from the paper, they match the WHO report. It's actually good data. And you can map all the numbers from all these papers and they match up perfectly. And then even after that, he's had to add these numbers to get what he wants. So it's just this sleight of hand to confuse people that he somehow got into the Washington Post. And now the other lab leak people, they cite this as evidence, as proof of their theory. But this is unlike Picard. With Picard, you can say, hey, your paper's wrong, and you eventually get an erratum. With him, you can go to him on Twitter and say, hey, this is wrong. And there's no peer review. There's no way to correct it. And it's decentralized. So there's, a dozen people like Guy doing this stuff that makes this lab leak hydra of all these weird false claims. It's also just hilarious that he thinks the Chinese scientists hid the data in plain sight, but that he could only read that their figure was wrong, or where the hidden information was. I'd recommend a Slate Star Codex, Astral Codex 10 post about this, explaining a modern misinformation campaign is a decentralized movement. It's not from the top where they're making the stuff up and disseminating it to you. They get people to participate. And that's what draws people into this. They like being lab leak researchers because it lets you feel important. It lets you feel like you're finding what China hid. And it's the same thing with QAnon. It's the same thing with lab leak. And I'm not saying a bunch of these people aren't necessarily bad actors. They're all just they found a purpose in writing these Bayesian analyses, the ones that you cited, and they get status with their community for saying these things. And Rootclaim, you're basically a part of this community. Now, you go on Twitter and there's one guy that says, hey, if lab leak's false, why can't you prove it to Saar Wilf? Why don't you just bet 100 grand? And most people in the world don't have 100 grand to bet. And they also don't have 6 months of time to go through every one of these claims and see why every single one of them is wrong. I'm the one weird person in the world that has both the time and the money to call you out on this. But I don't like this bullying tactic that's being used. And I think the community is creating bad information. I yield.
Saar, do you want to respond to that before I want to start focusing it? This is not helping me with my decision very much, so I want to start focusing it.
I agree.
Okay, so I want to start just in general. I need to understand the timing of cases better because they seem important for both of these theories and they seem like we can make some boundaries. Connor Reed, I'm going to have a trouble with merely just from the perspective that I'm unwilling to decide the entire course of this debate upon that single factoid. And there's a lot of things like that, which makes this very hard. I'll weigh it. The thing that would be more interesting to me is focusing on the timeline that you gave Saar and Yuri, what in your timeline, as I read it, there's about 200 odd cases prior to December 1st, give or take. Why don't those cases show up in the seemingly unbiased testing that Peter refers to, that where they go back and they test lavage samples or they test blood banks or things like that? Why, if those cases are floating around, doesn't at least one of them come up? I can reference slide numbers if it's helpful, but
Right. No, so I need to check exactly consent detail, but from first impression, you need to remember we're talking about low numbers. Okay, we're talking about perhaps 100 cases before HSM starts, and in a period where we have hundreds of thousands of flu cases. So you're not necessarily going to find all of it. doesn't necessarily, these people don't necessarily show up in these samples. I need to look one after another, but there's so many. I mean, you're looking for something that's a needle in a haystack, right? These are very low numbers. There's so many ways this could spread. It could be even that it's going at a very low rate, and then finds some super spreader location, and then it jumps for 100 and is enough to infect HSM. There's so many things that could happen when you deal with biology, people, politics. We can discuss and do modeling and
okay.
Peter is correct in that you can work and fit models, and in a sense, I'm not denying that my market model is something that was built to feed the data, because I'm not claiming it as evidence. I'm claiming it as counter evidence. What I'm trying to show is that all these claims that are based on to try to show how the market is a very low p-value for being the epicenter, there's so many ways they could fail. I'm just showing one of them. The one I'm showing is probably, yeah, sure.
Let me just stop it there. Okay, so one of the things that I've had trouble with the debate generally in these cases is that both of you are responding to each other without building a strong affirmative case for what the world looks like under your model, and it makes it difficult. So the reason I'm pushing on this question is because I don't want counter evidence. I want to know what you think the state of the world looks like in September 1st, whatever, and how that interacts with Peter's claim about those evidence. I get what you're saying in the sense where there is if we have 200 people who are positive, a lot of them don't go to the hospital. Maybe you have something like that, but I want to know what the state of the world is. So that's where I'm going for it.
Can you explain a bit about what are you looking to do with this, and maybe that'd be helpful too.
It just seems like it's going to bound the probability calculations when I do my own Bayesian analysis after the end here to be like, so if I think I can make a pretty straightforward calculation based on Peter's slides 112, 113, and 114 from debate 1, which are just from the WHO report about what kind of retroactive testing they did that never found any COVID. So like the thing I'm trying to figure out and why I asked for both of you to create those tables is because those seem like very strong boundaries on what theories are possible.
Okay.
I want to ask one more question in this vein on the basis of your presentation here, and that is why, if it's circulating, so it seems that we kind of agreed, or I thought that Yuri agreed, that SARS-CoV-2 does not spread like SARS-1. SARS-1 smoldered, and SARS-2 doesn't seem to smolder. That may be incorrect, so you can cut it off there. But if in your model right now it takes you think HSM is a very, very good place for it to spread, possibly the best place for it to spread, but it takes 2 months for it to start spreading there. It seems kind of unlikely that that's true. It seems like I've got a grant that it does low smoldering transmission and then pops out at the market. Does that seem like a fair assessment, or am I missing something?
No. So first of all, again, the claim about the dispersed. This is another new claim based on modeling data. We need to look at it. There's likely going to be like 10 mistakes in that. I would guess a lot of it is based on the fact that when they made this model, it was post-social distancing. So what happens is you have most people obeying, and a few don't give a damn and just go and infect everyone. So there's so many things that can go wrong with these models. Each one, you need to go and before you build any case on those, you really need to check how strong it is. So that's one thing. The other thing is, even if it's true, then what could happen is you have the lab worker going to some bar. I don't know, 20 people infected. Most of them die out. One of them affects another 20 people somewhere else, and then it gets to 100 and they just say, I mean, it's not. It can definitely be dispersed.
But why did it take over 2 months to get to the HSM?
Well, hang on. So then this will be my final, and I apologize. This is just very important for me. So I apologize for monopolizing it here. So this was the basis of my question in your presentation, which was I wanted you to estimate how much more likely, given the same person, same infectious characteristics goes to HSM versus goes to a Walmart, what does that look like in the terms of the difference that an outbreak would start there? And the reason I ask that question is because of this. If it does take, like, if I say that one person visits 5 places a day or 2 places a day or whatever, I can make some sort of calculation on how much more likely HSM has to be. So that's where I was asking for that specification. Do you think that is the wrong question to ask, or do you think that that's...
No, it's a fine question. The reason it takes time is because that's what we see in the genetic clocks. So you would probably go to a supermarket and maybe infect someone there, but again, the conditions and the number of permanent residents there is not enough to create anything that would be noticeable to authorities. So you need to have the virus coming in and have a lot of people that can where it can grow, and it will grow fast within them, right? You need all the conditions where these 1,000 people can have the virus grow quickly. That just won't happen in a supermarket.
Okay. Thank you. Eric, sorry, go ahead.
Yeah, sure. Okay, my number one question I'm interested in, I think, is not something we're going to be able to answer verbally very effectively. But I was looking through the different sources each of you gave in your slides, and we've spent a lot of time been looking at like assimilated like charts, diagrams, plots of where cases are and stuff. And the one thing I'd really like to have is just a list of all the first 100 or so known cases of COVID, who they were, where they got sick, did they go to the hospital, where they sequenced, what were the mutations. Is that information somewhere? Because there's only so much time I can spend looking at these, pie charts of genetically related things without wanting to know the nitty gritty, because it's hard to speak with confidence. What can we know about the distribution of early data when I'm only ever looking at summary data and never individual data points? So if either of you have references to where we can find like all the data, that'd be fantastic.
I could compile like the first 14, 15. I think it gets increasingly complicated as you get to like 200. And the first that's not anywhere near the market is Chen. And it's like the other 12 before that are the ones I keep showing where you have the wildlife stalls and those cluster right near there. That's like pretty much, that's like 12 out of 13 of the cases. And then like 13 is outside the market, but like 2 kilometers away. Something I think that's that family cluster that Saar talked about. Also, I don't want to pull up the slide, that'd take too much time, but he did that modified where it's like Picard's dot plot, and then he puts the family cluster over on the left. Do you remember that one? And then he puts A20 on there. You could do the same thing with the earlier B cases, because we know there will be a blue dot on like December 3rd when Wei Guizhang gets infected, because there has to be a case before her that infects her. So the fact that you just put extra red dots doesn't mean there's not also extra blue dots. That's misleading.
Sorry, did you want to say anything about early?
Yeah, so go ahead.
Did you want to say anything to my question about early COVID cases? Do you have a source?
Everyone wants to have the early case data, but sharing is very limited of the data, and it's only based on the data that somehow already someone worked on and published and can be collected, but no one actually did serious research into early cases and go into all the sources you can and do the best to find index case in early patients. And that in itself is very suspicious, but everyone wants what you're asking for. I'm sure Peter would be can very effectively find you the data we do have, but you need to remember this data is...
Yeah, but they also looked at like 80,000 hospital records for earlier cases, and and the ones that Will was talking about where they did the retrospective samples and the blood banks. And so there's a few things I really wish we had, like antibody testing at the market that could actually find patient zero, but you're really writing it off if they tested 80,000 hospital records and didn't find anybody. That is serious effort that you're ignoring.
Again, what is didn't find anybody? Yeah, they need to find him within hundreds of thousands of flu cases, right? So, yeah. So it's not that surprising that they want to find. I can look at each of these and find where the weak points. The bottom line, all of the evidence for zoonosis has multiple weak points that maybe exist, maybe they don't, but there are a lot of potential weak points in each zoonosis evidence. The best of the lab leak evidence that we presented don't have these weak points. We could have brought like a ton of research and studies and models that show lab leak is 100% correct. We just don't do that. We don't value that kind of evidence.
Could you summarize what about lab leak is unassailable? Why is it 100% true?
I didn't yield. So, but the only reason we're having this discussion is because the position does bring those studies. So that we need to go into finding all the weak points. And as I showed, there are many weak points that we already found. How many didn't we find, right? So, yeah. What did you say, Peter?
Oh, so I mean, you're acting like you're angry that you have to do research right now. And I think there's actually a big asymmetry on my side. It's called Brandolini's law. It's harder to debunk bullshit than it is to create bullshit. And every one of these things created by Gilles Demaneuf, that guy works nonstop to make these 200-page reports of misleading information. And I can't even read his whole 200 pages, but the parts of his work that I have researched have all been wrong. So I can write off that source as...
I agree. Same for Picard and Warby, yeah.
I've been working to disprove Picard and Warby. I didn't yield, by the way, Saar, so that's very rude of you. I've been working to debunk Picard and Warby for like 6 months, and I haven't found a problem there. So if I did, I wouldn't be here. I would have walked out of the debate, and I'd be a lab leak supporter. Yield.
Sure, but you do agree there are problems with Picard and Warby. So Picard had an erratum, so that's a major... a 10x correction to base factor. That's a big mistake, and that's the one we found. I have others I found, but I didn't have time to show them. If we can maybe add time for that. And Warby, again, all this using this checking data with this categorization of making a car fur count as a wet market. These things that's not good research. So I agree that all of these things are not reliable and they're bound to be wrong. If you work on each of those like very seriously for 1 year, maybe you can bring one of them to be evidence that is somehow competing with the FCS. That could happen. But most likely it will just disappear to lots of modeling errors.
So to be clear, they did spend more than a year of work on that paper. That's what scientists do. They don't just multiply together fractions to confirm their biases. They do years of work to do these papers. And because you can find, a bug in Picard's code that changes it by a 6x factor, I mean, if anything, that proves that his model has been tested, whereas like you can't test Gilles Demaneuf's analysis because he won't admit when he's wrong. And there's no way to even file an erratum.
Right. So you're pretending here that people are rational when they try to get studies published. They worked a year to find something that would be publishable, but they didn't. But someone else needs to work a year to find all the hidden mistakes and implicit biases and everything. So we had a bunch of people do that for a few weeks and find the erratum, but you need to do it for everything. They did it just for one thing. There's so many assumptions that they need to do it for everything, and that will eventually yield more mistakes probably.
What do you mean when you say you had somebody work to find the Picard erratum? Did you fund that research, or did that just somebody do that on Twitter? I'm just curious there.
It's not something I said. I said maybe you. I said you have people in the general.
Never mind. Just curious there. Maybe we should. We're just fighting. We're bickering. Let's let.
So another question for me. One of the things I'm kind of confused about, and this is just broadly. Kind of translating between the kind of the rhetorical, description of the Bayesian reasoning or of your model and what the actual calculations are. In several different places, like the furin cleavage slide is isolated or called out as unusual but ignored. In other places, it's like this is not the first time we'd find this in a sarbecovirus or whatever. Two-part question. Part number one. If the future sampling found a 99.9% similar virus in a bat cave, but no furin cleavage site, would you say more? Does that prove lab leak, or does that prove natural origin, or does it suggest? And question 2 is, if we just drop the FCS, is that a discount of a 50x? What's the discount? And I apologize, I think that's just my confusion.
Yeah, so if there's no FCS at all, it would be a bit more than 50, maybe 150. I need to look at the numbers, which is still leaves you 1000x of buffer before making all the corrections that I just mentioned that will increase the lab leak probability. So
Sure.
without that FCS, yeah, you're losing like 200, something like that. I need to look at it. If we find an identical progenitor to SARS-2 without FCS, I think Peter will agree it's a lab leak, right?
We never. I don't think we will find one, because in SARS, the closest we found was 96% similar, and that was after 20 years of searching, and we've already found 96.8% with SARS-2. So I don't think we're ever going to find the 99.5% virus. I guess it would depend where you find it. Like if you find it in the freezer at WIV, then I would agree it's 100% a lab leak. If you find it in a farm in, I don't know, Southeast Asia, and you could speculate that it still evolved, maybe that would be. This is really hypothetical and not relevant.
Okay, so let's answer that. So if it's identical to SARS-2 and just doesn't have the FCS, that means you're leaving a very little time for the FCS to emerge, right? So in terms of genetic clock, so like there's maybe a few months where the FCS can emerge, and that means even less opportunity for this rare occurrence to happen. So at that point, it seems to be very strong for.
Oh, if it's only exactly 12 nucleotides different, but even then you still need to explain how the lab got it. If it's found, it's not going to happen. It's never going to happen, because it would mutate in nature. It wouldn't be the same except for 12. So it's an irrelevant question.
So to answer your first question, so FCS appears in 3 different places in our analysis, and they're independent. We're not double counting. One is the fact that it's an FCS is the feature that helps it be infectious, and WAV and diffuse are talking about FCS. So this match is one thing, but not a big thing. The other thing is that the way the FCS is cleanly inserted, right? So in the CGG, all of this genetic stuff. And then the fact that it's the first FCS in subecovirus, right? So these are 3 different evidence pieces related to FCS, and they're all independent.
Okay, let me sharpen.
So can I bump in just briefly? He said something about, I found the 15 nucleotide insert in HKU1, and I also found 12 nucleotide inserts in flu. And Saar waved those away as saying, oh, we should always find those in HKU1, and we should always find those in flu. But in sarbecovirus, there's no chance. Why do you conclude that, Saar?
Right, so we have statistics. We know it doesn't happen in any sarbecovirus. Specifically, the HKU1 case, I think the insert is, depending on, you need to look at the exact nucleotides, but I'm guessing the best alignment would just show this is SSSSS insert, and that's a pretty common duplication to happen. Insertion, it's not something that...
It was NSPSS, I think.
Yeah, but I think that's one alignment. I think we'll need to look at the nucleotides to see, but it looks like something that's much more likely to happen. You just have...
That's just your gut feeling, though.
Yeah, I agree. Maybe I'm wrong, and we look at it, and it's amazing insert, but first look, it just looks like a duplication of the S 5 times.
I have a question.
And the flu cases you bought, you see that there are multiple inserts. So you see this area.
But we have more flus to compare across, and we only have 2 sarbecoviruses that spilled over into other animals, or maybe slightly more if you count the pangolins, so like 4 or whatever. Right. So you're saying it's a 1 out of 4 thing, and you can't compare the bad ones because it's favored against.
No, because in SARS-2 you see the whole area is very well conserved for decades. So you're looking at many viruses, and they're all conserve this area very, very well. Not all of them, but many conserve this area very well. And then you have just this perfect insertion. Same, nothing flanking has been changed. Everything's very few synonymous mutations on each side. That's very different. Yeah. And also, it's from a non-viral source. It's not it's not like RRRRR, right? It's not like something that would you can understand how it happens. There's no idea where this thing comes from. Where did these 12 NTs suddenly get shot into this location?
Judges?
Peter, while we're talking about this, I just want a quick question. How closely related is HKU1 to AYR 18599.1?
I don't know.
Because we're talking all this time about this 12 nucleotide insertion in SARS-CoV-2 compared to Banal 52, and we established earlier they're closely related.
Oh, what's the total nucleotide identity?
Right. If we're going to be making this, you made this mock theory with HKU1, and a little question of 99% similarity or 90% similarity is not a little question. We need to know.
I can look it up for you. I can pull them up on
I would want to know.
GenBank or whatever. That'd be interesting.
There's nothing deeper there. I just want to know the number.
Yeah.
Sorry, and this is again a viral. This may be my lack of viral genetics background. I don't understand what clean insert means. Clean insert seems to be a function of what level of sequences you've collected around it. So like if you compare two things that are distantly related, a bunch of stuff is going to look like a clean insert. Like what does that mean? This is not I'm just trying to understand what when that term keeps popping up. Like I understand
So the thing is you look at the area flanking the insertion.
Yeah.
And you see this is a well-conserved area with only synonymous mutations for maybe 100 nucleotides on each side. And you need to look again at the alignment. So it's not an area where you're constantly having mutations, insertions, deletions. This is not a noisy area compared to the closest viruses, which are about 20 years back.
But what would an unclean insert look like? Like what does that term mean?
So it's not the insert that is clean. It's the area. So if you see like an area which constantly has insertions, and you see in all related viruses they all have insertions there, then that's unclean.
Okay, so it's the probability in that area. Okay, thank you.
Yeah.
Sorry.
Okay, ready for a new topic? Sorry, I wanted to ask you, I have a hard time getting to, you gave a 10% probability that the first, obviously this is speculative, 10% probability the first cluster would show up at the Huanan seafood market, assuming the location it shows up as unrelated to patient 0. And I have a hard time getting to that with the other numbers you've given. So assuming that the market has 50,000 unique weekly visitors and that an infectious person is infectious for a week, say, then given the population of Wuhan, for every one sick person to visit the market, you have 245 sick people who never once go to the market during their period of contagion. And you've spent some time arguing that the market is a highly favorable location for spread, but even if it is infinitely favorable, that doesn't change the fact that other locations still sustain spread of COVID. Like I don't think you're going to dispute that after December 2019, there was spread of COVID in locations outside of the market. Obviously, COVID can spread outside of the market. So I want to know how, if we have 245 people not visiting the market and one visiting the market, none of these 245 started any cases, or started any like clusters, any events. How come we don't see any cases before it ever even saw the market?
So first of all, it's important to remember that we've seen wet markets involved in other outbreaks when there's COVID-0. So we're not bringing some crazy claim here. This is something that you've seen elsewhere. So if it's 10% or 5% or 2%, it's not going to change much because we're looking for 100,000, and still the evidence in the market does not look like wildlife. So it's still going to be maybe a bigger coincidence, but still the evidence doesn't support it. So you still need to accept it's a coincidence. But to your question, so you have the other people infecting around, but most of them don't infect anyone. some of them may infect like their family, may infect people at work, at the train, and these people just go from this location, then disperse and maybe die out, maybe infect others. It's a more uniform event across Wuhan and a slower one. Okay, so it happens at a slower rate and it's more uniform. So you're not supposed to see many clusters. You could have a super spreading event. I'm not saying it doesn't happen, but when you have few people, then you have less opportunities for a super spreading event. But HSM is unique in that it brings 10,000 people every day. So it brings when you have 100 people infected, it brings the virus every few days in. So that's something unique. And once you combine that with the high growth rate and the persistent population, where this can grow quickly, they just the sick person goes to the mahjong room and then you have 40 infections, right? This is all very noisy stuff, and it can grow very quickly. So that is why it's different. Does that answer your question?
You didn't actually prove that other places don't have 10,000 visitors. That's important. You said you don't believe the social media check-in data, but any Walmart or shopping mall in town could also have 10,000 visitors. So you're still comparing all these other places where it can go. You can't just calculate the odds that it goes to the market. You need to compare against the other ones somewhere else.
I don't think Walmarts would have 10,000, but definitely train stations. These places would definitely have 10,000. They just don't have the capacity to keep the virus in. That's all.
But you didn't prove that the growth rate is high at the market. I proved to you at the beginning of this debate that that's counterfactual to the data. It doesn't grow faster in the market.
You didn't prove. You showed some evidence that doesn't sit well with the model. I can sit and look into it and think what it is. But again, I'm not claiming this model is perfect. I'm just showing how it is impossible to claim 10,000, 2,000, 100, these kind of base factors for this very noisy data that involves biology, humans, politics. There's so many things that can go wrong. I just showed an example of what kind of things could go wrong. I'm sure, 100% sure this model is not perfect. But I think that if you work on it more and more, it will eventually get there.
I'm 100% sure that 10,000 is not the exact number either. And if this were like a good debate where we were comparing real models, I'd be happy to figure out how biased the data is at all. But your current model, like you say right now, it's 1 in 10, but you didn't even put the factor of 10 in your analysis. You put a factor of 1 in your analysis. So yeah, I don't understand that.
It's stronger than a coincidence. I explained this multiple times.
So are the other 10 all markets?
No. So another one is the Baishazhu market is a good location, and others are.
What are the other 8?
Meat processing plant could be one of these locations where we've seen it. It can also be that it won't be an early cluster. It could be just that it's uniform. A lot of things could happen.
But we're comparing the odds of zoonosis relative to the data versus the odds of a lab leak relative to the data. And if it's zoonosis at the market, it's 100% based on it, the first cluster being at the market. But if it's lab leak and the first cluster is at the market, that's conditionally lower. You can't say that's 100%. And you've completely ignored the market data in your analysis.
Right. So I explained this multiple times. Do the judges understand it? Because I don't want to waste my time explaining it to Peter. So if the judges know why I put 1x, even though it's 10%, then we can just skip this.
Do you guys understand it?
Can you give me a 15-second reminder?
Yeah. So you need to compare you need to choose the best explanation. Okay. So there's 2 ways to get to HSM happening. It's because the first infection is there, and because the first infection is not there. If it's not there, it's 10%.
You're arguing that even under zoonosis, you think it did not happen at the market.
Exactly.
Okay, yes, I understand that argument.
Because the evidence within the market does not support wildlife involvement. So
okay, I understand the argument. I did want to ask, but again, I don't want to take away from any more interesting questions that Will might have. I did want to ask Saar about the model you presented in today's session. I understand, of course, that this is a qualitative thing. You're not trying to be like numerically exact. You're just trying to present a story of how this could be consistent with the data. However, I think that you're ignoring something important that significantly changes. I mean, again, it's all like, you adjust the numbers however you want. You can get up or down or whatever. But when we talk about how many market-linked cases there are versus how many non-market-linked cases there are, every time a transmission happens, there's a probability that it goes from having a known market link to not having a known market link because the retrospective epidemiological analysis fails to observe the link. In this way, you can have a pandemic that even if it started in the market, you have a lot of non-market linked cases just because not because they're not linked to the market, because we don't know what the linkage is. I think if you add in a probability with each transmission that a case becomes not market linked, not for some physiological reason, just because we fail to discover the link, that it becomes much harder to replicate the numbers that you're getting. So you suppose that at the market case, let's just say that market cases double twice as fast, that the exponential is twice as high at the market than outside of the market. But if we additionally say that every transmission, and I chose the number, didn't get the result I wanted, if we imagine that 1 out of 6 transmissions, you lose the link to retrospective analysis, then even if all cases are market linked, you'll get a steady state of 2/3 of cases have a known market link, because the market linked cases keep growing faster and faster, but they're also constantly seeding non-market linked cases. Obviously this is hard to explain verbally, but I think you understand.
No, I understand perfectly.
Do you want to respond to that?
So 2 points here. One is because the exponent outside the market is smaller, then it's not that significant. Okay, so it seeds outside, but within weeks, what it seeded is negligible. And the other thing is we see in Shinfadi that all the cases are concentrated in this basement with seafood, and all cases were traced to that. So of course, they're not identical, and Peter has made good points about that. But just to show that it is possible to trace all cases to the market. 100% were traced.
I think I hit most of my most important questions. I don't know if, Will, you want to ask?
This is most of mine. I mean, genuinely, I think most of my remaining questions are going to require me to look very deeply and compare the things. I don't think there's anything else glaring that's sticking out to me or like where I needed to clarify or understand. I presume my process at this point is just going to be going over slides, looking through the presentations, and then, making my final analysis. I'm just looking at my...
Peter, I have a question for you. I don't expect you to know the answer, but what was...
I am the premier expert in the world, we've established.
What was WIV doing if they were not doing the diffuse research or similar research?
So I did include slides in my first presentation where I tried to track down what Ben Hu and the other 2 researchers were doing at the time. So you can look at the papers I provided there, which the closest I can do to providing an alibi. I think Ben Hu was working on some viruses from Kenya at the time. They don't focus just on sarbecoviruses. And I did provide in my second presentation a history of all their gain of function research done at the lab, or all the experiments done at the lab, and I classified which are gain of function. So all these people are busy, all of them are publishing 4 to 8 papers per year. So there is actually not a huge room in there for them to do the secret project in the first place. That would be my best guess.
Okay, thank you.
Maybe I can kind of pick up on where my pre-debate 3 questions were for you, Peter, and kind of understand this initial transmission event. So basically, construct for me, on the basis of reading that response, you think that it's likely that somebody is not sick, brings a animal in, there's just generally abortive transmission, or kind of there's not sufficient transmission in the location, whatever farm this is on, and then they just happen to bring in one or multiple animals with harboring multiple strains, and then that transmission kicks it off. Is that right?
Absolutely. Yeah. And I hope my written explanation was pretty clear on this, because it's really the same thing with SARS, where we never found a farmer with SARS. We never found SARS cases in Yunnan. We never found SARS cases in Hubei, the two, most likely origins for the pandemic. We never found like guys driving SARS to the markets. What we found was SARS cases at the markets and the restaurants. And Rootclaim does make a good point about like, why isn't a restaurant? I don't actually know if there are restaurants in Wuhan that are selling civets still. That would be my guess. But if they want to provide proof that there are such restaurants, that would maybe change the odds and the base factor of my calculation.
It doesn't have to be Wuhan. It could be any restaurant anywhere.
But it has to sell a wild animal is the point. It's not just, a sizzler can't start a sarcoidosis.
Okay, so that makes sense. I think the difficulty, or like the thing that it's the idea that these cases have not been identified, or like the kind of progenitor, the early pre-index cases for the pandemic have not been identified, seems like a combination of retrospectively, it would be hard to go back because you would have no, like, once the pandemic swept through everywhere, you're not going to be able to distinguish when those people got it. It seems like there's a second factor floating around in the debate, which is the idea that China doesn't want to find this answer internally. So those two I understand from your answer. The level of current sampling going on in those bat caves, the kind of, what do you expect or what do you understand to be how much sequencing we're doing of potential origin locations for SARS? Basically, what I'm getting at is it is somewhat odd to me that we have not found the progenitor or a closer progenitor, but it's not totally unreasonable for all the arguments we've given. So can you speculate about what's going on there?
Oh, so I mean, the closest virus they ever found for SARS was 96% similar, the bat virus. And the closest one we found for COVID is 96.8% similar. So we're actually doing better with SARS-2 than SARS-1. Also, we can't really sample in China anymore for political reasons. So that closest one was in Laos. I assume if you could sample in Hubei, Yunnan, wherever the right caves are, you would have a chance of finding a better one. They could have solved this in 2020 during zero COVID for sure, with they could have talked to the traders. They could have done the antibody testing at the market. They could have gone back to more farms. They could have done antibody testing at those farms. Could you solve it today? I'm not super optimistic, especially now that COVID's gone through China and everybody's going to have antibodies.
Okay, so that all makes sense. But I thought even in the SARS case, it was one cave had been found that contained all of the pieces, like not in the same virus, but I mean, this was based on a TWIV episode.
There's the recombinant ancestors is another thing where you could say, like, we didn't find the 96%, but if you combine these bad ancestors, you get something closer. And the recombinant for both COVID and SARS is 99%. That's in my week 1 slides. I provide a link to that. So it's similarly, I think maybe with SARS, the recombinant pieces you would use would be more co-localized. And in SARS-2, they might be slightly more spread out across like Laos and Yunnan. So it might not be a single cave. But also they did that 5-year-long project in that single cave, which is probably why you have those pieces. And another thing is, sorry, I'll let you click my time. Like Saar keeps saying, oh, we're not going to find COVID on the other side of town because the hospitals can't find it. I think that's not true. I think that's just something that Gilles Demaneuf made up. But because it wasn't this early warning system that found the cases, it was actually the people like Ying Xingjian that found these cases that look like SARS. But even if you did think that was true, that case is so much more true in rural China because that farmer's not going to go to a hospital at all. They're not going to meet anyone that has SARS experience. There's just zero chance they're going to get recorded. So it didn't happen with SARS and it didn't happen with COVID. And even like it didn't happen with the Hong Kong hamster shop. I thought that was an interesting paper where you had the 2 spillovers from the same shop. And, the first cases recorded are in Hong Kong, not in like the warehouse for the hamsters. Could be more, not recorded.
Okay, I do not have any other pressing questions prior to some more deep dives.
Yeah.
Eric?
I'd be happy to add 5 minutes if people want to give closing remarks. If they don't, that's also fine.
Sure, I'll do. Do you have a closing remark, Saar?
I don't think I need more than a minute. Let me just check if there's anything big I didn't say. Okay, I can use 5 minutes. I'll do
Do you want to go first right now?
Huh?
Do you want to go first right now?
I prefer to go last, but I'll do it. It's fine. Maybe I'll leave me just 30 seconds if there's something big that you say and I didn't.
Or whatever. We can do the other way. I'm not trying to.
I was thinking Peter went first in the.
We can do a coin flip.
Okay. So, the last point I want to make is to help you focus on what's important and how do you assess probabilities when there's so much information. So what I'm going to do here, I'm going to look at something about contradictory high base factors. This is something that's not supposed to happen. You're not supposed to have two hypotheses with, say, over 100x base factor. Let's look at the example. Suppose you have two hypotheses. One is that the die is biased to 6%. The other is that the die is biased to 50%. So, for example, if you throw a 6 5 times in a row, that's a 1 in 32 event under H1 and the 1 in 100,000 under H2. Okay, so that's the ratio between them is the base factor for 6 5 times in a row. So that means it's very unlikely to have reliable reports of 5 1s in a row and 5 6s in a row. Okay, it's because that means 2 events of 1 of 100,000 have somehow happened. It's not supposed to happen, and this is something that is a major point in the way that Peter presented the probabilities. He got to this 1e25. That doesn't happen in real probabilistic analysis. It's impossible to get to these numbers. So you don't have these kind of coincidences. So that's the main point. Now, let's think that what happened. Suppose you have these two evidence. One is you have a clear, reliable video of someone throwing 5 1s in a row, and then you have a testimony that says, "My friend told me he rolled 8 6s in a row." Okay. Now the latter is claiming a much higher p-value, right? It's claiming a 1 in 100 million p-value. But we need to choose the best explanation. The best explanation is that your friend just misinterpreted or lied. So the situation where you have a high base factor for the wrong hypothesis is either because you did a lot of comparisons, so maybe you threw the dice 100 million times and you got there, but for 100x you did hundreds of trials, or it's not reliable. In our case, what we have is there is reliable, strong lab leak evidence that is not. It's not going to change. It's not. We understand it very well. And all the zoonosis evidence, strong evidence, is based on all this complex modeling, which has sharpshooter fallacies, garbage in, garbage out, manipulated data, modeling mistakes, etc. So, if I need to summarize all my case to one sentence, you can sit after this and build your models and look into how many cases were at October and if it started or it grows smoothly and uniformly. You can do that, and then at the day you need to look at two things. You need to, for zoonosis to be correct, you need to explain why this is happening in Wuhan, in this lab that is probably doing exactly the work that would result in a SARS-2 with all these features, bad coronavirus with the ACE2 mesh and everything, and then it has this clean 12 nucleotide insert exactly in the FCS, which is exactly what these people are working on, with the non-virus salt, with CGG, right? And you have no other spillovers anywhere in the world. You don't have any phylogenetic evidence that there have been multiple evidence. Maybe you have 1 and 2 nucleotides apart, maybe in the same location at the same time. But we look at MERS, we look at SARS-1, we look at the MINC reinfection, look at HIV. All we have is lots of spillovers, 10, 20, 50 spillovers, dozens of nucleotides apart, large genetic diversity. We don't have that here, and we don't have the intermediate host. Because that's what you need for zoonosis to be correct. You need to explain these things which are very hard to explain. For a lab leak to be correct, all you need to assume is that people were people. They did bad modeling, they manipulated data, they did mistakes in their codes. That's all that needs to happen. That is guaranteed to happen given the politics, given how people work, given all the interests around this. It's just guaranteed to happen. And I leave my 30 seconds for the end. Go.
Sorry, is it me? You yield the screen, please. All right. Yeah, so I guess respond to a few of those things that just Rootclaim keeps saying they always come up with the best explanation for everything, and most of their best explanations are not actually the best explanation. Like the double CGG, the best explanation is that is favored based on the protein folding, and that would evolve towards that. They ignored that. Like the best explanation for why we don't have an infected positive wildlife trader is because that's a 95% chance that you miss the average COVID case. And also that person doesn't have an incentive to admit that they're patient zero. The best explanation for no tested animals is simply the fact that they did not test any live animals. And if you put probabilities on those things, they would be in the like 90+% range. The best explanation for the pandemic, I mean, it's like Wuhan's bigger than New York City. And imagine that New York City had like 4 exotic pet shops, and this brand new virus, bringing viruses in or bringing animals in from Africa or, some exotic place. And you have a brand new virus that starts at one of those pet shops, and the first 12 people are there. And then all the cases radiate out from there. This is like in Manhattan. And then somebody makes a theory blaming like a lab in Queens, saying it's got to be the lab. I mean, that's pretty simple. All you need to do is have nature, have millions of viruses, and they all mutate. I agree with Saar. You're probably overwhelmed and confused at this point because you've heard so many different theories during this. I think that's kind of the point of the lab leak theory. It's not designed to be consistent. It's designed to be confusing in a political sense. This was started by Steve Bannon. His media tactic is called flood the zone with shit. It's not about persuasion. It's about disorientation. This is not top-down conspiracy from him. I talked about with modern misorientation movement or misinformation movements, it's about these amateurs who work as a community to come up with the theories, and then these are used to confuse the public. It's the same with election results. It's the same with vaccines. It's the same with climate change. And I think the judges should cut through the noise and see what's going on here. The lab leak side can't even stick to their argument even during the debate. Their hard evidence is just it has a furin cleavage site, and I don't think that overwhelms the other evidence. They've declared all the official data is either fake or biased. They've retreated to a tabloid story. They think that's 100% true, but all the WHO data is 100% false. And I mean, there's still some uncertainty on the origin of COVID, but there's always going to be some uncertainty. And if we let the noise win, it's actually going to harm our ability to prevent the next pandemic. At some point, if the natural origin side wins here, I suspect the lab leak people will just try to ignore this debate. If the lab leak side wins, they'll say the lab leak theory is proven true. You just have to watch 20 hours of complicated discussion to understand why. That's like when they tell you to read the Christian Anderson Slack messages, which are way more complicated. I think there's a risk here because I'm putting more of a risk for science than I could possibly gain, but I'm an optimist. I think lab leak will win its day, or natural origin will win its day in court. I think it's really important to have the right answer here. This could influence elections. I mean, lab safety is important, but damaging our relationship with China will actually reduce biosafety because we don't know what they're doing anymore. We can't do these sampling trips to China anymore that we need to understand viral diversity. We've got this witch hunt to look for the scientists who created COVID, but we're not actually doing anything to regulate the wildlife trade. And the next pandemic could be H5N1 on a mink farm. It could be another SARS-CoV-3. China's not doing anything because they're saying they think it's an American lab that made the virus. So that's going to be another 20 million people dead because we're focused on the scientists when we should actually be focused on the real problem. Like, these are the safety practices at the Wuhan lab versus the safety practices at the South China, the Huanan market. They're standing in pools of blood and taking no precautions. Wildlife handling is done at BSL 0 with millions of animals. They have viruses. Many can potentially jump species. And if we ignore this and the only way, these millions of species can mutate at any time. All we have to assume is that evolution over millions and millions of viruses eventually figured out one way to create a furin cleavage site. And we need to understand that this is how viruses work and make the changes to prevent the next pandemic. That's what I got. Yield.
Saar, would you like to use your last 29 seconds?
Yeah, sure. So some people are saying that probabilistic analysis is not the only way, and it has some weaknesses, but basically the only alternative he's offering is looking who is wearing lab coats and who has weird ideas. I don't think that's much better. I think probabilistic analysis is the way to evaluate something this complex, and I think we did it well and got a very accurate result. He showed the BSL-4 at WIV. The problem is this is BSL-2, so we're likely to cause it. He didn't explain why Wuhan. He just said it's a coincidence, like New York. Okay, so everything stands.
Why Wuhan is, it's a 1.5 to 5% chance. And if it was any other city, you'd make a similar theory because that's what people do. In China, they think it's for Detrick, and that's half of China. So there's hundreds of millions of people that think that's true. And probably somebody there is doing a Bayesian analysis, and they're just as convinced as you are.
Maybe.
Okay. Well, that concludes. I think you both did an incredible job. This is certainly a public service, obviously done in the pursuit of, glory and riches. But, it's incredible to see people put this much effort into something like this and to come up with such cogent analysis. So I don't think, I'm extremely impressed. I have a lot of work ahead of me. I feel privileged to get to participate in this. So thank you, guys.
Thank you.